Okay, good day, class. Uh, Today, we will discuss about the derivative of algebraic functions. Now, previously, we have discussed about how to find the derivative of a certain function using increment method. So that is finding the derivative using finding the limits of the function as the delta y over delta x approaches, finding the limits of the ratio of delta y over delta x as delta x approaches 0. Now, today, I will show you some helpful formulas to determine the derivative of algebraic functions. So, no need to use increment method, that is long solution to find the derivative. But it is important to note that all of these formulas are derived from the increment method. So now let's discuss. So there are several formulas that we will encounter here. So first is the derivative of a constant. So the derivative of a constant is equal to 0. So when you take the derivative of a constant, it is always equal to 0. Okay. Next, suppose u and v are functions of x. Then the following formulas are helpful in finding the derivative of functions. So first is the derivative of a sum. So the derivative of the sum of two functions is equal to the sum of their derivatives. So if we are asked to find the derivative of u plus b, then we simply first determine the derivative of u and v separately and then add the two. So next, derivative of a product. The derivative of the product of two functions is equal to the first function times the derivative of the second plus the second times the derivative of the first. So in a mathematical sentence, it is expressed as the derivative of u times b is equal to u times the derivative of v with respect to x plus v times the derivative of u with respect to x. Now, there's a special case here. Suppose we want to find the derivative of three functions, of product of three functions. Suppose u, v, and w. Now, formulas 2 and 3 can be extended to the case where n functions are involved. So this is applicable for more than two functions. So let's say we have an example. For example, we have three functions u, v, and w. Then the derivative is as shown here. Okay. Now, lastly, we have the derivative of a quotient. So the derivative of the quotient of two functions is equal to the denominator times the derivative of the denominator minus the numerator times the derivative of the denominator, all divided by the square of the denominator. So in mathematical sentence, it is shown in formula 4. Okay, so there is a special case here, class. It is note that in the special case where our numerator is constant, that is our u equals c, then the formula 4 is reduced to a simpler form, that is formula 4 prime here. And the formula 3 is also reduced into a simpler form, that is the formula 3 prime. So, okay. Next, mayroon pa pala. Okay, the derivative of x raised to n. So the derivative of x raised to n is simply n times x raised to n minus 1. So, okay. Now let's solve some problems. One of the application of differential calculus is to solve for the vertex, for the slope, for the points of inflection, etc. And the solution using differential calculus is much simpler, shorter compared to the solution of analytic geometry. Although both can be employed to solve for the problems involving graphs, involving functions. Okay, now let's solve first our sample problem now. One. Uh, okay, find the vertex of the parabola by means of the derivative. Check by completing the square and putting the equation of the parabola in standard form. Okay, class, we will have two solutions for this problem. One, using differential calculus, that is solving for the derivative first. And second, using analytic geometry by converting the general equation into its standard equation. Okay. Okay. To better appreciate the solution of the derivative, let us first solve it using analytic geometry. Okay. So, so we have our solution one. Suppose, let's write first our equation, x squared plus 4x plus 3y plus 1 equals 0. Now, we need to convert it into the standard equation of a parabola by means of completing the square. So, consider these two terms, x squared plus 4x. So, what is the missing term so that this term will become a perfect square trinomial? Okay, that would be x squared plus 4x plus 4. Okay, now let us transpose these two terms to the right side. Negative 3y plus 1. And since we add a plus 4 here at the left side to balance the equation, we must also add here plus 4. Okay, now this expression here is equivalent to x plus 2 squared. Now this becomes negative 3y plus 3. Okay. Now I think, well, let us factor out negative 3. So x plus 2 squared equals, okay, negative 3, y minus 1. So y minus 1 is equal to negative 1/3 x plus 2 squared. So, okay, that would be the standard equation of the parabola. Now, from this standard equation, what can you say? What can you infer from this standard equation? We know that the standard equation of a parabola is expressed as like this. Y minus k is equal to 4a times x minus h squared. This standard form class is a parabola that opens either upward or downward depending on the sign of the latus rectum, which is 4a. So in our case, our latus rectum is negative 1/3. Therefore, it opens downward. Then our vertex hk of our parabola hk is equal to okay, negative 2 and 1. So that would be the vertex of the parabola, and it opens downward. Okay, so if we graph this parabola class, what would be the graph of this parabola? So let's first find the vertex, negative 2, 1. So suppose it is located here. So this would be negative 2 and 1. Okay, and our parabola will look like this. Oh, sorry. Yeah, like that. So class, we know that this is symmetrical about this line. That would be x equals -2. And our directrix is located here. So this is just a review of your analytic geometry. And our focus is located here. Okay. Now, using differential calculus, how do we solve this? This would be using analytic geometry. Now, for our solution to, let's write here solution to. Solution to. So let's first express y as a function of x, meaning we isolate y in the left side. Okay. So our y would be negative x squared minus 4x minus 1 all over 3. Okay. Now, let's just distribute this divisor. We have negative 1/3 x squared minus 4/3 x minus 1/3. Okay. Now, let's first solve for its derivative. Okay, y prime. So what would be our y prime? Here, class, you can, the first term, how to find the derivative of the first term. Okay, this is using a formula. First, we use our formula 3 prime, the product of a constant and x and the function of x. Next, we use our formula for the derivative of x raised to n. Okay, now what would be our derivative? So it will become negative 2/3 times x, and here the same, the formula 3 prime minus 4/3. Now the derivative of a constant is 0, so that would be 0. Now we know that the graph of this, we know that the vertex of this parabola is located at the top because it opens downward, and it is the apex of this parabola. And since it is the apex of this parabola, we can say that the slope of the parabola at that point, that is the vertex, must be 0. And from our module 2, the slope of a function or curve is identical to its first derivative. So we just equate our y prime to 0 because our slope at the vertex is 0. And we solve for x. So our x would be, okay, cancel, -2. So that would be our x, -2. So what would be the value of y? So going back to our function, when x equals -2, our y would be refer to this equation, negative 2 squared minus 4 times -2 minus 1 all over 3. So what would be the value of our y? Okay. So the value of our y, going back to our mode 1, our equation is negative x squared minus 4x minus 1 over 3. So we input a value of -2. So our y is 1. Just as the same here. The same that we compute here. So our value of 1 is y. So therefore, our vertex is at -2, 1. Okay? So ganyan lang class ang pag-solve ng ating derivative. Okay? Now, let's move on to the next problem. Find the points where the tangent is parallel to the OX. Okay. So, okay, what type of function is this? Y equals x minus 1 all over x squared minus 2x plus 5. This is called a rational algebraic function. And if you remember in our module 1 lecture video, module 2, I have shown how to graph rational algebraic function. So if you want to graph this class, just refer to that video and it's very easy, okay? So in this case, we are asked to find the points where the tangent is parallel to the OX. So what is OX, class? OX is simply the x-axis, okay? So if it is parallel to the x-axis, then the slope of that point, the slope of the curve at that point must be 0 because it is horizontal. Okay, so same as our problem set 1, sample problem 1, we equate our derivative to 0. But first, let's find the derivative of this given function. Okay, x minus 1 all over x squared minus 2x plus 5. Okay, this is what, class? This is a what can we use? What can we use to solve this derivative? The derivative of a quotient, class. But remember, class, before you use the derivative of a quotient, make sure that the degree of the polynomial of the denominator must be less than the degree of the polynomial of the denominator to simplify the derivative. Okay, so if it happens that the degree of the polynomial of the numerator is higher or equal to the degree of the polynomial of the denominator, then first use a long division or synthetic division, whatever you like, before you solve for the derivative. Okay, now, since in our case, the numerator is the degree is 1 and the denominator is 2, then we proceed to the determination of the derivative. Okay, so okay, I'm gonna write first the derivative of a quotient so that you can follow. It is equal to the wait. Pangit ang sulat ko, class, sorry na. Okay, so this is the formula for the derivative of a quotient. So first, before pala tayo derive or mag-differentiate, differentiate, let us first try to see if the denominator and the denominator has common factors. And if that is the case, we should cancel out the common factors, okay? But in our case, wala siya, plus wala. Okay, so let's proceed. So our u here is equal to x minus 1 and our v here is equal to x squared minus 2x plus 5. Okay, so our let's go. So that our y prime would be first v. Our v is x squared minus 2x plus 5 times the derivative of u. So our derivative of u is just 1. Since this is x, derivative is x, and -1 is a constant, so the derivative is 0. Minus minus u, x minus 1 times the derivative of our denominator. So using the formula derivative of x raised to n, so this would become 2x minus 2. Okay, plus 0. Okay, so madali lang siya, class. All over x squared minus 2x plus 5. So to find the point that is parallel to the x-axis, we simply equate this to 0. Okay, now this becomes x squared minus 2x plus 5 minus, let's first distribute this one. Okay, this would become 2x squared minus 2x minus 2x plus 2 equals 0. So this becomes x squared minus 2x plus 5 minus 2x squared plus 4x minus 2 equals 0. So this becomes negative x squared plus 2x minus, tama ba? Negative, negative? Tama. Plus 3. Plus 3 ba? Wait lang. 2x squared minus 2x minus 2x plus 2. Okay. Negative 2x squared minus plus 4x minus 2. Okay. This becomes negative 2x squared plus 3 equals 0. Okay. Now let's multiply this by negative 1. So this becomes x squared minus 2x minus 3 equals 0. Now, to solve for its roots, we can either use a quadratic formula or simply we can factor this out using by factoring. What would be the factor of this one? That would be negative 3 and 1 equals 0. So our x must be equal to 3 and our x must be equal to negative 1. Okay. So, but we are asked to find a point. Since we know the abscissa or the x coordinate, we just substitute it to the given function. What would be the given function? Okay. So now let's our given function is x minus 1 all over x squared minus 2x plus 5. Okay. At x equals 3, what will be the value of our y? Okay. So let's go back to our calculator. So our function is x minus 1 all over x squared minus 2x plus 5. So when our x is 3, our y is 1/4. So when at x equals 1, what will be the value of y? So when x equals 1, our value of y is 0, of course. 0. Sorry. This must be negative 1. So negative 1. Negative 1. Negative 1/4. Okay. Negative 1/4. So when x is 3, 1/4. Negative 1. So therefore, our 2 points is R, 3 and 1/4 and negative 1 and negative 1/4. Okay. So ganyan lang siya, class. Very simple. You can solve it. You can study this within a day. Okay, so that would be all. Next, in our next lecture video, let's discuss about the chain rule and the general power formula. So, okay, thank you.